In 1980, 3 siblings were each given $1,000 as part of an inheritance from a deceased uncle. You think that's something real that might happen?
Yes.
Could be, right? Okay. The siblings agreed to invest their money individually and come back years later to see who had amassed the most fortune. Do you think that's something that happens? Probably less likely, right? Okay. But understand, I can't always have the perfect word problem for you every time. So we're going to go with this one this time, okay? All right. So the oldest brother, Alan, put $1,000 into the bank. Each month he would add $62.50 to the account for a total of $750 per year. You okay with that? The sister, Bernice, invested her $1,000 in various money market accounts and earned 12% interest each year, which was compounded annually. Does that sound familiar? Okay, good. Carl, the youngest, put his money into technology stocks. Their value climbed according to a parabolic curve until it peaked at $20,600 in 1994. By 2008, the stocks had fallen back to the original value of $1,000. Sus, right? That's what happens, though, if you bet on risky stuff. Okay? But at least his stocks are still at 1,000, right? Okay, so that it would be worse if it was at 0 or, if he owed somebody money for it or something like that, right? Okay, so first thing it wants us to do is match the histories with the graphs. Do you think we have enough information to do that?
Yes.
Match the histories with the graphs? I think so too. Okay, so which graph goes with which sibling?
The one that goes like up and then around is definitely C.
So this one? So the parabola, you think, goes with the one that says parabolic in the words?
Yes.
Oh, I think that's a good guess. Okay. So this is Carl. So we're going to say Carl is the parabola. And what kind of a function is a parabola? Quadratic. That's exactly right. Okay, quadratic. Okay. What else do you think you might know?
I feel like the I think A is the one that's just like straight up.
So you think the Allen is a line.
Yes.
Why do you think the Allen is a line?
He puts the same amount in every
He puts the same amount in every year. So then that means this would be Allen. That's linear, isn't it? When the same thing happens every time, that's linear. Same thing being added to the account every time, right? So Allen is a line. His function is linear. Okay? Well, that kind of narrows it down for us, right? Hopefully we can figure out who the last one is. At first I thought you said Susan. I was like, who is Susan? No, Beatrice, right? We know this is Beatrice. Well, think about it, guys. Does this language seem familiar to you? 12% interest, compounded annually. What kind of functions did we just deal with that dealt with that kind of information? Oh no, oh no, oh no. It is, right? I even called her, after we even made fun of the wrong name, I even wrote the wrong name. Sorry. Oh no, oh no. Bernice. Bernice, sorry about that. Sorry, Bernice. Sorry about that. Okay, Bernice. So Bernice, what kind of function did you say it was? Logarithm or exponential, right? And looking at the shape of the graph, you know that this is exponential, okay? Now, I didn't correct you when you said logarithm because we did deal with logarithm problems that had interest in compounding annually, right? We absolutely did. But looking at the graph when we're trying to decide if it's logarithmic or exponential, you would know it's exponential because that's very similar to a parent function shape, isn't it? Okay? Okay, now that we know which scenario goes with which graph, now I need the equations of those. Do you think we have enough information here to be able to write the equations of those? I do too. Okay, so let's see what we can do. Which one do you think is the easiest to write? Probably Allen's? with the line, okay? What do you think it should look like? What's a linear parent function look like? Uh-huh. Yeah. And being what? So it's the slope, right? It's how much it changes every time. And then b is the y-intercept or the original amount, right? So what can we put for Alan? 750 x plus 1000. Why are we using 750 and not the $62.50? That's per month, right? And it's asking us to deal with years right here, right? So we definitely want to use the 750 instead of the 6250. You okay with that? Okay. What about Bernice, whose name is not Beatrice, it's Bernice. Okay. Exponential, what's parent function for exponential?
A times B squared.
To the x, right? Good guesses, good guesses. A times b to the x. But you know that now that I say it, right?
Yeah.
You could definitely remember that. Okay. What was A again? The starting amount, yes. And what's B? The common ratio, right? I have no idea what it's doing. It's fine.
Make sure it's not separate.
It's not. I'm trying to move my mouse every so often so it doesn't, stop, whatever, so I can see if it does. Okay, so A times B to the x. A is the starting amount, B is the common ratio. What's the starting amount? 1,000. Okay, so that's super easy to think about. Times B. Well, guys, another thing that we talked about with B was it was 1 plus or minus R, right? That was especially true when it was compounded annually. And look, haha, compounded annually, right? 1 plus or minus R. Well, can we use that for this problem? Yeah, if we're going to do 1 plus or minus R, is it going to be plus or minus?
Plus.
Definitely plus, right? We're earning that interest. So what do I just put? 1 plus 12? Oh, no, that's not right. 1 plus 0.12, which would be 1.12, right? To the x power. You guys okay with that? All right. Last but not least, we have Carl. Our good friend Carl. Maybe he's not our good friend. Maybe we don't even like him. But we still have to work with this information, right? So I'm going to go to my Wait, do you guys remember how to make an equation of a quadratic? Is it okay if I remind you? I know you know how to do it. No, that's a good try though. But before we can do quadratic formula, we have to know the general form, right? So what I need something is an equation in this form. Y equals ax squared plus bx plus c. That's what I need, right? Okay.
All right.
It's a good guess though. It's a good guess. It sure would be nice if they had given us 3 points of data. Oh, they did?
Well, they have the years.
Don't we have 3 points of data? Okay, let's write them out so that we're all clear on what the 3 points of data is. Is that okay with you? Okay, so I need a point x, y, but I need to know what I'm using to represent x and what I'm using to represent y. Is there any context clues we can look at to figure that out?
Well, X looks like how much money, or Y looks like how much money.
Y looks like how much money, and x like how many years, right? That's perfect. So if I say x, y, x being the years and y being the money, what do I know about what he started with? He started with 1,000, right? What's the year when he started? 1980, right? Can I use 1980 as my point? It needs to be how many years since I started. Well, if I'm talking about when I started, what's my x value? 0. Absolutely. 0, 1,000. Any idea what the next data point is?
What's
Okay, so that's our y value, right?
Yeah, by 1994, so 14.
Oh, wait, where did you get 14?
Because I added 1994.
You subtracted?
Yeah.
Yeah, right. Or in your head, you added, you said
Yeah.
what adds to 1980 to
Yeah,
get to
that's what I
1994.
remember.
Perfect. 14. And you're telling me we also have a third data point?
Because we went back down.
Oh, went back down to what?
1,000
1,000?
by 2008.
So what's my time when the year is 2008?
14.
I know it involves more subtraction, right? Close. This one was 14.
Wait.
It is
Wait,
14 years
from
since here, right?
1980?
But what is it?
Oh, from 1980.
Yeah,
Oh, 14 plus 14 is 28.
28. Okay. So is it okay if I remind you how to find an equation of a quadratic when you have 3 points?
Yes.
Now, I know at least 2 ways in the calculator. Is it okay if I show you the way I like the best? And then if you don't like that way the best, I can show you another way. Is that okay? Okay. So what I would do first, here's what's also a pain about this, because you know I have to zoom way in for the calculator to be clear on the video, right? Or on the screen. So I'm going to try to zoom in where you can see the calculator and my 3 points. You okay with that? Okay. Do you remember what to do from here? If I just give you this screen, can you tell me what to do? I mean politely.
Go down
Mm-hmm.
to 4.
Yeah. We need to start a list and spreadsheet. Okay? We need to start a list and spreadsheet. What are we going to call this column right here? We absolutely could call it X. What else could we call it that would make sense for this problem?
You could call it year.
Absolutely, you could call it years. Isn't that what the X value is representing in this problem?
Yeah.
So is it okay if we type that in?
Yeah.
Could you call it X though?
Yes.
Absolutely 100%. Okay? But I have 0, I have 14, and I have 28. Now what do we want to call this column? Money. What else could we call it?
Oh wait, what?
We could call it Y. We could call it amount. We could call it Franklin if we wanted to, right? But that wouldn't really make sense in the context of the problem. So here I have 1,000. Benjamin Franklin, you're totally right. Sorry about that. 20,600 and then 1,000 again.
And then menu.
Menu. No, not menu.
No, not menu.
Nope. Good guess. Because menu does this, and I don't need that. Control doc. Control doc adds a new page, and the new page I want is, good guess. Data and statistics. Okay. So I need to move my cursor down here and click. What is my x-axis represented by? My years. And what is my y-axis represented by? Money. Now I need the equation. Do you remember the steps to get the equation? Can I help? Okay, menu. Analyze. So I'm just going to press number 4. Regression. So I'm just going to press number 6. Now you tell me what kind of regression I'm finding. What kind of equation did we already decide it was? Quadratic. Do you see number 4 says show quadratic? Boom. There it is. Are you guys okay with that way, or do I need to show you a different way? You okay with that? Okay. So this is negative, oops, let me zoom back out. Sorry. Negative 100 x squared plus 2800 x plus 1000. Now, does that equation make sense to you in any way, shape, or form?
Yes.
In quadratic, what do you know that the c is also called? When it's in standard form like this, the c is your y-intercept. Does that make sense? Yeah, right? I know c has to be 1,000 because I know that's my y-intercept. So we're probably good, right? Now it says check the equations using a graphing calculator with a domain of x is between 0 and 28. Okay, so I need to add another page. That is a graph. Sorry, you can't even see that at all right now, so let me zoom in. Okay. Yes, control doc to add a new page and a graph. Okay, so the 3 equations that I just came up with, I'm going to enter into the calculator. Okay, so we said 750x plus 1,000. I'm going to hit tab again. I'm going to put in 1,000 times 1.12 raised to the x power. And then I'm going to put in negative 100, tab, negative 100 x squared plus 2,800 x plus 1,000. Now, usually at this point in time, this is when you guys panic. Because it doesn't look anything like I think it should look. Right? I know what it should look like. Right? This does not look like that. This is typically when you panic. What's rule number 1? Don't panic. Look back at the question and what does it ask for you for? Check the equations using your graphing calculator. Oh yeah, it actually wants a different window, doesn't it? Menu. Window. It wants a domain between 0 and 28. Guys, if I'm changing my x-axis, don't you think I really ought to change my y-axis as well? Think about the context of this problem. Think about even the graph you're already given. Would it make sense for my y-min to be 0? Yes? Okay? Because we're talking about positive money amounts here, aren't we? Okay? What do you think my y maximum should be? That's my x, that's my years. Remember why it was representing money? What kind of money values do I have in this problem? Think about just my parabola. What kind of money values do I have in my parabola?
Big ones.
Yeah, like 20,600, right? I want to be able to see my vertex of my parabola though, so is it okay with you if I put in 21,000? Does that make sense? Oh, see, that's much better. Doesn't that look like that? That's much better, isn't it? Okay. Now, there's even a benefit of what we just did. Yeah, it's nice and good. Our equations are good. But look at what the next question asks us to do. Use the function to complete the table. Oh, man, I wish I had a table to compare it to.
Control T.
Control T. Control T. Brings up my table. So I want to know first about Alan. Can we just look at Alan's information? In the calculator, what did we call Alan's equation? It should be F1, right? F1 is Alan's information. So can we go around the room and call these out? Here, I'll show you what I mean. I'm going to arrow down. I'm at F1 right here. I'm going to arrow down to where when x is 5, what is y? It is 4,750. Does that make sense? Well, what about when x is 10? What is y? Okay, somebody else tell me when x is 20. 16,000. What about when x is 25? 19,750. Good. Okay. Now, what's Bernice? What is her equation called in my calculator? F2, right? So I need an arrow over so I can see that table really clearly. And I need 5.
1,762.34.
Why did you stop at 2 decimal places?
Well, it shows you at the bottom, but
It does, right? It stops in the box, but it definitely shows you at the bottom. So why did you choose to stop at 2 decimal places? What does our Y value represent? Money.
and there's only
And what do we round in money? Always 2, right? Okay, unless it tells you to round to the thousand or something like that. But cents is usually what we deal with in money, right? Okay.
Are we gonna be round? Oh, wait, never mind.
Okay. What about 10? Can somebody tell me what 10 is? Okay, 3,105.85. What about 20? 9,646 and 29 cents. And what about 25? I'm just going to argue a little bit. I think it should be 0.06. I know in the box it says 0.1, but if you look down at the bottom, it rounded a little early for us. You okay with that? All right, what about Carl? In our calculator, what is his equation called? F3. Okay. So what about at 5 years? What is Carl's amount? 12,500. What about 10? 19,000. What about 20? And what about 25? Okay. Now answer a question for me. At the end of 5 years, who had the most?
Alan.
Hey guys, look at these numbers right here. Carl.
5 years. Oh,
Yeah. What about at the end of 10 years? Who had the most? Carl, because that's 19,000. That's the most, right? What about at the end of 20 years? Who had the most? Dang, Carl. And what about at the end of 25 years? Alan. Okay so far? I've seen lots of ways to spell Alan. I have a friend who is A-L-A-N. I've seen A-L-L-E-N. I've seen A-L-L-A-N like this is.
I've only seen ALEN.
It's okay. It's given that Carl had $1,000 after 28 years. How much did the other siblings have at this time?
28.
28. I need you to tell me 2 different ways to find out these answers.
Just look at your chart.
So go in the calculator down to 28, right? Okay, so if we do that, we're going to say Alan had 22,000 and Bernice. Wait, is that the right name? Okay. $23,883.86. Ooh, who's going to end up on top? Use these graphs of these functions on the calculator to answer the question that follows. There's at least 2 ways just on the calculator to answer these. Is it okay if we do it the way I think is easier? I'm going to show you both ways just to make sure. Well, I'll let you decide. How about that? I won't even tell you which way I think is easier. How about that? Okay. After approximately how many years did Alan and Bernice have the same amount of money invested? What are we trying to find? Where they intersect, okay? So how could I do that using the calculator? So I need to get rid of the table?
Yeah.
Can we talk about the way using the table before I get rid of it? Okay. So we said a minute ago that Alan is F1 and Bernice is F2, right? So I could scroll, 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 scroll until,
Well, how'd you get on the split screen like that?
what do you mean? Control T?
Yours says to show us both of them. Yeah, ours only shows one at a time.
I don't know, mine's better.
Oh,
No, I have no idea. Can you go back and forth with the arrow though? Does that help?
yeah, you go back.
Okay. So I'm just trying to find two that are what? The same, right? Can I find two that are the same?
No.
Not exactly the same, not in this problem. I can find two that are close. It looks like it's about 27 years, but I don't really have any way to know that for sure. Because it's not exactly 27 years, right? So what are you wanting to do? I'm going to get rid of my table, you said, Control T. And what are you wanting to do? Okay, first of all, I'm going to Control click that equation and I'm going to move it because it's in my way. And I'm going to Control click, nope, not that, not that. Control click that equation. I'm going to move it over here out of the way. You okay with that?
Yeah.
So you want me to do menu,
Analyze,
analyze.
and then intersection.
Oh, look, intersection. What is it asking me? Which graph am I talking about? Well, I need Alan and Bernice, right? Alan is the
F1,
line, and Bernice is the,
F2.
so exponential, right? So it's saying left bound and right bound, or lower bound and upper bound, excuse me. Oh, it even changed my window, didn't it? God bless you. So here's what mine says, in case you can't see it. You saw it for just a second, but I got to zoom back out so I can write. But just to make sure, mine says 27, 2.12 E4. Is that what yours says? I need to translate that into English. After approximately how many years did they have the same amount of money invested? How do I know it's approximately 27 and not exactly 27?
Because the second number is not.
Yeah, the second number is not a clean number, and we just look at the table, and the value in the table weren't exactly the same, right? So it's rounded this for room, so I'm going to put about 27 years, okay? And then what was the amount? Well, I got to translate this from math into English. It's how many zeros? 4. Well, it's 4 places after the decimal. So I already have 212, but the decimal used to be right here. So 1, 2, 3, 4. Does that make sense? Guys, if I go back and look at my table real quick, Control T, when I was at 27, this said 21,250, and this one says 21,324. That's pretty close, isn't it? Okay. So we're good, yes? Okay. After approximately, wait, hold on a second. Can I write on this for a second? This was Carl, right? And then Alan, and then Bernice. So we were looking for the intersection between Alan and Bernice. So we were looking for that intersection right there, weren't we? Okay. So what if we're looking for Alan and Carl? Which one are we looking for? That one, right? So I'm going to get rid of my table again. Alan and Carl? Uh-oh. Thank you. That one. I don't want to erase that because we're going to find it in a second, but we're really talking about that one. So that'll help us when we look at this graph, won't it? Let me zoom in again. So it's that one that we're looking for, right? Menu, analyze, intersection. And I need that one and that one. From there to there. So what mine says,
It'll do that sometimes. You have to just click on the graph. So click on the line.
it's making you do that. I'm going to do it again, watch. Menu, analyze, intersection. Look what it's asking. Graph, because there's 3 graphs on here and there's not a place where they all 3 intersect, except right down here, but even then we need to tell it. Which graph are we talking about? We're talking about this one, and we're talking about this one. Second graph, we're talking about that one. I click and click. Then it asks for lower bound and upper bound. So I put it on the left side of the intersection and click, and then on the right side of the intersection and click. Does that make sense? Okay, so what it told me was 20.5 and then 1.64 E4. So translating that to English, tell me please.
About 20 and a half years.
About 20.5 years. And how much money was that?
16,400.
Because here's where the decimal point was. I need 4 spaces after that. You okay with that? Now, is that something I can check on the table? 20.5? No, right? Because it goes from 20 to 21. I don't have a 20.5 on my table, do I?
I didn't even use this paper very well.
Okay. I'm going to keep talking until the bell rings. On this one, I want you to circle 4, 5, and 10. But like I said, I'm going to keep talking until I'm done with this, so you'll be able to come back and watch this video if you need to. Okay? All right, number 7, Bernice and Carl. That's this one, right? That's Bernice and Carl right there. So using my calculator again, menu, analyze, intersection. Bernice and Carl from here to here. And it says, mine says 22.7 and 1.31 E4. Okay, so translating that into English, I have about 22.7 years, and I have 131. I need 4 spaces after the decimal, so 1, 2, 3, 4. So $13,100. Okay. Now, one of the problems above can be solved algebraically, that is without a calculator. Which one do you think it is? Okay. Well, if you think back to this, what it's actually asking us to do is solve a system of equations. Okay. Up to now, we've done systems of linear equations. This has a linear equation in it, but it is not a system of linear equations because they're not all linear. Okay, but if I'm going to try to solve either exponential and a quadratic, or a linear and a quadratic, or a linear and an exponential, chances are I'm going to have the best luck if one of those is linear. Okay. Now, I'm not saying that we couldn't solve a linear and an exponential. I think it would be easier to solve a linear and a quadratic. Okay, so if I'm going to solve the linear and the quadratic, I need to write both of those equations down. Okay, the linear being 750x plus 1,000, and the quadratic being negative 100x squared plus 2800x plus 1000. Oops, sorry. 750x plus 100 or 1000 is the linear function. Negative 100x squared plus 2800x plus 1000 being the quadratic. Remembering back quite a bit to when we solve systems of equations, when we're trying to solve this, what we're trying to do is we're trying to set these two equal to each other. Okay? So if we're setting these two equal to each other and we're solving it, this is a quadratic, so I need to get this equal to 0. So I'm going to subtract 750x from both sides, and I'm going to subtract 1000 from both sides. 750x minus 750x is 0. 1000 minus 1000 is 0, so that side is what I need it to be. Okay? On this other side, I have negative 100x squared. 2800x minus 750x is 2050, or 2050x. And 1000 minus 1000, also 0. That's good luck for us, because then we just have to try to solve this smaller equation. Notice that they both contain an x, so I can factor an x out of each term. That leaves negative 100x plus 2050. Now, if I factored this out correctly, and I did, and I multiply these two together and I get a 0, this is the zero product property. So what do I do with each one of these factors? I set it equal to 0. Okay, well, this one's already solved for, right there. To solve for x in this problem, I need to subtract 2050 from both sides, which gives me negative 100x equals negative 2050. Dividing both sides by negative 100 gives me x equals 20.5. So that is my other solution. Now, if we think back to this, this is actually what we solved earlier in problem number 6, because we said it would be easier to solve Carl and Allen. When we solved Carl and Allen, look at what we got for our answer. So we could actually correct this answer at this point, because it's not only about 20.5 years, it's exactly 20.5 years. Okay? But it's a good thing we got the same answer. That's always nice. Okay? Solving a system of nonlinear equations can sometimes be tricky, but we're not going to let it be. Okay? We're going to refer to the second worksheet that I gave you today called Systems with Geometry. Okay? Systems with Geometry is really the heart of the matter. Okay? So many different times in geometry when we're given equations to solve with algebra. Okay? So they go hand in hand. They are related very closely. Here's what I want to look at, so you can see why we're talking specifically about geometry. Okay? A rectangle has an area of 36 square units and a perimeter of 25 units. Can you see any time that might be like a real problem? Maybe building a garden, maybe building a frame, any sort of rectangle that you're trying to actually build with, I don't know, wood, plastic, whatever you're going to build your rectangle with, right? This is something we might know, and we might know the area because it has to fit somewhere, or we might know the perimeter because it has to fit in a certain place. We need to find what dimensions we should use. Okay, so how do we go about finding area of a rectangle? Length times width, right? Well, length times width equals area. So xy equals 36. What about perimeter? How do you find perimeter? Well, most people say you add up all the sides, right? Well, how many x's are there? There's 2. And how many y's are there? Again, there's 2. So 2x plus 2y, that should equal the perimeter, which is 25. Okay? So there's a couple different ways to solve this. You know that. We could do graphing, we could do substitution, we could do elimination. But Either way, it would be a lot easier if they were both set equal to y. Because if they were both set equal to y, we could either graph them or we could set them equal to each other. Okay, so let's get both of these equations set equal to y. If we're solving the top equation for y, I would divide both sides by x. So y would equal 36 over x. Second equation, in order to solve for y, I would have to subtract 2x from both sides first to get 2y equals 25 minus 2x. And then to solve for y, I would have to divide everything by 2. That would give me y equals 12.5 minus x. So y equals 12.5 minus x. Okay, so at this point we could graph it, but I would like to practice the action of solving by substitution. So if y equals 36 over x and y equals 12.5 minus x, would it make sense that y would equal y? Does it make sense that 36 over x would equal 12.5 minus x? Hopefully your answer was yes. Okay, and if I put this over 1, it might be easier to see how you would go about solving this. One fraction set equal to another fraction, I can cross multiply. 36 equals 12.5 x minus x squared. Well, once you see that x squared, you know that's a quadratic and you know you want to get it equal to 0. I'm going to subtract 12x from both sides, or excuse me, 12.5x from both sides, and add x squared to both sides. Do you remember why I would move those two things over here rather than move the 36? Yep, because it would keep my x squared positive. Is that required? No, it makes it a lot easier though. Okay, so x squared minus 12.5x plus 36 equals 0. Now, I know some of you would like to factor that, and I'm not saying it's impossible, because it's entirely possible, but it is hard sometimes to think about two numbers that multiply together to give me 36 and add to be a decimal, because there's a lot of other numbers that you can use just besides the typical integers that we normally use. Okay, so the best thing for this might be to solve with the quadratic formula, with a being 1, b being negative 12.5, and c being 36. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. So that's just a matter of going to a calculator page on my calculator and putting in 12 point, oh, let me give myself a fraction, 12.5 plus, remember I have to do this part one at a time, the square root of negative 12.5 squared. Remember, since it's negative, I either need to ignore the negative because I know I'm squaring it's going to be a positive, or put the 12.5 into parentheses, minus 4 times a times c all over 2a, which in this case is just 2. It's always nice when it comes out to a nice integer number, in this case a whole number, right? So x equals 8. Now the other option I need to do is exactly what I just did, except this needs to be a minus. So my possible x values are 8 and 4.5. Now hopefully you realize that if I have two possible x values, then I have two possible solutions. One x value is 8 something, and one x value is 4.5 something. Remember that? These are both x values, so I have two possible solutions with these as my x values. Now I can choose either equation to substitute it in to find out my y value, but both of these equations are already solved for y, so these would probably be easier. Okay? Y equals 12.5 minus 8. Well, that's 4.5. Y equals 12.5 minus 4.5. Well, that's just 8. Now, will it always work that way, that these are just kind of flip-flopped? Not always, but in this case, x times y equals a particular number. So if this x times this y equals 36, then it doesn't make sense that this y or this x times this y would also equal 36. Hopefully it does. Okay, so that's how we're dealing with this worksheet about geometry. Okay, systems with geometry. So would you please circle number 4? Would you please circle number 5? And would you please circle number 10? Okay, those are the 3 that you're responsible for this evening. I know that's not a lot of problems. That's only 3 problems, but I know you won't be sad. Or I hope you won't be sad, because you can always do more if you want, for extra credit. Okay?